As you notice, some periodic tables do vary on the numbers just because it is quite hard to quantify them and get an absolute number for each one, since everything typically is based off carbon, and some things may change here and there based on how many significant digits you're going towards. So, number 8. How do you determine steric numbers? So, funny enough, actually, I don't know if you caught on what I said earlier, but when I was doing this question here, number 6, right, I said attachments, but this is actually what's known as the steric number. Okay, this right here, see 2, 3, 4, 5, 6. Steric number is, okay, I'm gonna write this slowly so you can really get my handwriting, hopefully, is the number of bonds and lone pairs attached to the central atom. Okay, so this right here is what a steric number is. So now how do we actually apply this? So say I give you an element, and it looks like this. Okay, what is its steric number? Alright, so the way you find that out, actually, you just count, starting with the bonds. So we have 1, 2, 3. Sorry about that, I don't like the way that bond looks. So we have 1, 2, 3, and then we add the electrons, the lone pairs. So it has to be lone pairs, so you don't count individual electrons, you count the whole thing of a pair. 1, 2. So this right here, this element would have a steric number of 5. Okay, now let's think of practical examples. If I gave you H2O water, what would the steric number be? We use the same concept here. Circle in each, I'm blanking on the word. You circle in each bond, then you add the lone pairs. This has a steric number of 4. Okay, and as it does mention here, it is used in Vesper theory, and it's used to exactly determine molecular geometry, which is actually what we're doing here this whole time. Based on the steric number, we could figure out its angle. So hopefully that even clarifies the previous question here. And what makes this even cooler is that, as you notice when I mentioned sulfur, things like sulfur, phosphorus, those are the ones that break the typical steric numbers. Most things like to be around 4, as you see with oxygen. Even, for example, nitrogen is another good example where you think it's different, but when you count it again, you have 1, 2, 3 bonds, 1 lone pair, 4 at the steric number. So most things prefer 4. There are a few examples, I guess, other cases. Those will include like phosphorus and sulfur, and then hydrogen only has really 1 bond, so it doesn't. I'm pretty sure it doesn't have a steric number. If you can technically, you can say 1. It has a steric number of 1, but yeah, that's what you do there. But yeah, count the number of bonds, okay, and then count the number of lone pairs, add them together. That is your steric number, okay. And if you notice that you're not getting 4 for like most things, you just be wary, because that should be typically what you should be erring towards, unless the whole worksheet is just about like really rare cases. Okay, this is correct.